Happy day to you all. This is Orekoya Olusegun on YouTube, Physics Mathematics Fundamentals. Today, we are going to derive the formula for the length of an arc and another formula for the area of a sector. Before we go into today's discussion proper, please don't forget to share, like, and comment on my page. Thank you. Now, let's start with the length of an arc. Consider the following circle. Let's take parts of the circumference called the arc of the circle. We want to know the length of arc AB. Arc is a fraction of total circumference of a circle. Let's say we have the center 0 of the circle and the radius OB as well as radius OA. This particular arc, let's say it sustains angle theta at the circumference of that circle, at the center of the circle, sorry. Now, we want to find the formula for the length L of the arc. How do we do that? Just remember to draw two boxes. Equate them to each other. Let the first box be for the length and the second one be for the angle. The first box, let's call it length box, and the second one, let's call it angle box, the box for the angle. Now for this length, let's put the length of an arc as L divided by the total circumference of the circle. Let's say circumference C. As we are drawing the angle sustained at the center by the arc of length L, let's say it's theta, you put it here, and the total angle sustained at the center of a circle is 360 degrees. We write that here. So we are looking for the formula to calculate the length of an arc. What we need to do is to make L subject to the formula. So we write L is equal to theta by cross multiplying theta divided by 360 times circumference of the circle. And the circumference of the circle, in my other YouTube video, I derived the formula for circumference using calculus, and what we have is 2 pi r, that is 2 times pi times radius of the circle. So in a nutshell, the length of an arc is theta divided by 360 times 2 pi r. If we want to express the same length, instead of in degree, we want to express it in radian. We know that 360 degree make 2 pi in radian. So we write theta. So our angle now is not going to be in degree, it's in radian, divided by 2 pi, then times 2 pi r. So the 2 pi cancel the 2 pi. So the length of an arc in radian is simply theta radian times r. That is for the length of an arc in degree, and the same length of an arc in radian. Now let's find the formula to calculate the area of a sector. Look at this sector, this particular sector. Let me bring it out. This is what is called sector. A sector is covered by 2 radii and an arc L. So we want to find the formula for the area AS of a sector. We can still use these boxes, but in this case, instead of using a length box, we are going to use a area box against the angle box. So now let's draw the two boxes. The first box is for the area, then we equate it to the second box, that is for the angle. So this second box is for the angle. So the area of the sector, let's call it AS, area sector, and the total area of a circle, you know, when we have a circle, or made by the area, is this region that is bounded by the circumference of the circle. That's the total area, area C of the circle. So we write area of the circle, that is AC. AS is area of the sector. So now for the angle sustained by this sector at the center is theta. So we write it as theta. And total area of a circle, in my last video on YouTube, I derive the formula for area of a circle to be pi r square using calculus. You can refer to my video on how to derive the area of a circle, which is pi r square. So I put pi r square here, and now make area of sector subject to the formula by cross multiplying. So the AS now will now be theta divided by pi r square times the area of a circle. No, sorry, theta divided by 360. The total angle in a circle is 360. So divided by 360, then times area of a circle. So we have theta divided by 360 times, like I said, the area of a circle is pi r square times pi r square. So this is the formula for the area of a sector. So don't forget, like I said, we equate two boxes. One box is for the area, the other box is for the angle when we are deriving the area of a sector. For the length of an arc, one box is for the length, the second box is for the angle. We just do the normal cross multiplication. Now, if we want to express this area of a sector in radian, we simply, instead of having this angle in degree, we are going to have the angle in radian, and 360 degree is 2 pi. 2 pi in radian. So we say times pi r square. So the pi cancel pi. So we are going to have a theta in radian times r square divided by 2. That is the same area of a sector in radian. Please, like I said the other time, kindly help me to like, share, and make comment on this video. Have a nice day. Thank you.